presentation at El Rancho de las Golondrinas Living History Museum. Now, before we dive into tonight's presentation, my colleagues and I were discussing that we're seeing a lot of new faces tonight at the lecture, and we're very excited about it. So we're a little curious to see how many of you are here from Las Golondrinas, one of our volunteers. Excellent. How many of you are volunteers or members of the Museum of Art? Awesome. How many of you are here with the Geological Society of New Mexico? Oh, not as many as we thought. Okay. So the rest of you are just interested in geology. That's great. All right, well, welcome everybody. Welcome to the 2024 Winter Lecture Series, Speaking of Traditions. El Rancho de las Golondrinas has been putting on this lecture series since 1999, making this the 26th year. We are happy to partner with the New Mexico Museum of Art in presenting this lecture series and are grateful to host it in the premier venue of Santa Fe, the St. Francis Auditorium. At this time, please remember to silence your cell phones. That was perfect timing. At the end of this lecture, I ask that you all exit the auditorium and wait to speak with Jayne in the lobby, as the museum needs to close shortly after. Everyone can support both Las Golondrinas and the New Mexico Museum of Art by becoming members or volunteers. It makes a difference and goes a long way in supporting both of our organizations. You can learn more or sign up on each of our respective websites or join on your way out this evening. For those of you watching this broadcast later on the Golondrinas live sessions, post any questions in the comment section and they will be answered. Be sure to check our website for details about our other lectures this year. On February 27th, we have Dr. Steve Lexon speaking on colonial Spanish documents in relation to cultural and archaeological sites we know today. And on March 26th, we have Dr. Tom Chavez speaking on his latest research about Benjamin Franklin and Spain's support of the American Revolution. I expect to see you all back here for those lectures as well. But tonight, we are honored to have Jayne Aubele speaking on New Mexico's geological landscape and its effect on our culture and social history. Jayne is a geologist and adult programs educator for the New Mexico Museum of Natural History and Science. She has specialized in volcanology and planetary geology and worked as a field geologist for the U.S. Geological Survey mapping the geology in the southwestern U.S., and for NASA remotely exploring the geology of Mars, Venus, and the Moon. Her extensive publications include scientific papers, geologic maps, curricula and materials for teachers of all grade levels, and chapters and articles for the general public in books including Volcanoes of North America, The Geology of Mars, and the Field Guide to the Sandia Mountains. She was an invited author for entries on comparative planetology and Earth, Macmillan Encyclopedia, and for a publication about geoscience in natural history museums in the 21st century. She was technical advisor and on-air geologist for the New Mexico PBS programs, The Sandias, and the New Mexico PBS video, Sleeping Monsters, Sacred Fires, Volcanoes of New Mexico. Prior to coming to the museum, she worked as a research scientist at Brown University, working with both U.S. and Russian planetary missions to Venus, and was a program manager for NASA's statewide space grant program. She is currently working on geologic maps of Venus for NASA. She is past chair of the GSA Planetary Geology Division, past president of the New Mexico Academy of Science, and a fellow of the Geological Society of America. In May 2023, she was notified that the asteroid 13481 Aubele was named after her by the IAU, International Astronomical Union. And now, without further ado, please join me in giving her a big, warm welcome, Jayne Aubele.
Thank you so much. I'm delighted to be here, and thank you all for coming. This is terrific. Okay, let's get started right away because the geology of New Mexico is amazing. Okay, I like to start by talking about what geology actually is. You might think rocks and minerals, maybe volcanoes, earthquakes, mountains, maybe even deserts, but it's also oceans, rivers, deltas, soil development. It's basically anything that affects a solid planet's surface and interior. The cool thing about geology is that it also incorporates all of the other sciences and the field of history, because we're talking about the element of time here, the way things change with time. So just as this building, an old schoolhouse in the Rio Puerto Valley, has stories to tell, the mesa and sandstone behind it also have stories to tell. And in fact, we can think of geology as a four-dimensional science, the three dimensions of space and the fourth dimension of time. And rocks actually tell a story. They tell a story about a time period, an environment, and geologic processes that formed them. So you will frequently hear geologists talk about reading the record in the rocks. But actually, the landscape itself also can tell a story of a time period, an environment, and geological processes that have formed it. And this is particularly true in New Mexico. So I like to say you can read the record in the rocks, and you can also read the story in the scenery. And sometimes they're two different stories. But in general, New Mexico is a perfect place for this, because the landscape in New Mexico, when you look out a window, you're looking at what's called primary geological processes. If you see a mountain, it's there not because it's an old eroded massif, but it just relatively geologically recently uplifted or erupted. And geologically, New Mexico's landscape is relatively young, dynamic, and still forming. So let's take a look at the landscape of New Mexico. Here are the four corners states: New Mexico, Colorado, Utah, Arizona. And this is a digital elevation model that kind of enhances topography. So take a look at the topography here, and I think you can see some sections that kind of look different. And you can see them even better once you have lines around them. But you can see a difference here between this area, looks like a can of worms, this area that's relatively smooth. Something's going on here, and this kind of circular region here. You're probably familiar with the concept of biozones, ecozones in biology. This is kind of the geological version. This is what we call physiographic or geologic provinces. And geologists have actually divided the crust of the Earth into these various sections. And each section has somewhat similar or related rock type, age of rock, and processes that have affected it, produced it. And of course, we give the provinces names. So here you see Basin and Range, Colorado Plateau, Great Plains, and Rocky Mountain Province, and something that goes right down the middle of the state of New Mexico that we'll talk about in a minute. Now, as a geologist, I have to show you at least one geologic map. Okay, so here it is. And I know it looks like a mess, but believe it or not, this is a simplified version. Now, the colors represent a sort of similar rock types and ages of rock, okay? So if I draw those same lines that I had before, I think you can see that these provinces actually have similar colors, similar rock types, and ages of rock. And New Mexico especially is, again, unique and special in that we arguably have more geologic provinces that come together as a nexus in our state than I think any other state. So look at this, we have 7 different geologic provinces. Each one of those has a specific grouping of rock types, ages, and geologic processes that have formed it. So as you go around the state of New Mexico, you can actually begin to recognize and understand the geology based on where you are and what province you're in. So we are going to take a super quick tour of the state of New Mexico by going from province to province to province. And we're going to start with one of my favorites, the Colorado Plateau. Okay, the Colorado Plateau, it's classic John Ford movie Western scenery. Okay, it's mesas and buttes and beautifully colored rock. What's forming this is it's all composed of flatline rock types, sedimentary rocks like sandstone, shale. They're all from the age of dinosaurs, what we call the Mesozoic period. Geologists call this layer cake geology, one layer on top of the other. Each layer represents a different time period, a different process. And then these layers have been eroded into mesas, buttes, and punching up through them in a few places are old volcanoes like Shiprock. So this section, not good for agriculture, but actually the home of the ancestral Puebloan people who figured out how to grow crops in this area, and later the Navajo. Railroad settlements came later because it was relatively flat and they could go up and down grades. And this type of rock is great for economic resources such as coal and, unfortunately, uranium. Okay, we are going to move from the Colorado Plateau across this boundary line right here. And that is called the transition zone. It extends, of course, into Arizona. We're dealing with the Four Corners states here. And in Arizona, it's known as the Mogollon Rim. You might be familiar with it. It's got topographic expression. In New Mexico, not so much topographic expression, but what you're looking at are faults that are in between two geologic provinces that have experienced different things. And so this packet of faults makes for some vertical disruption of the landscape, but it's also a great place for volcanoes to come up. So this is an area where we have some of our beautiful, big, and young volcanoes. Mount Taylor, Cabazon Peak, the Zini Bandera field where El Malpais is. Of course, Mount Taylor is also the sacred mountain for Acoma, Laguna, some other pueblos, and for the Navajo. This is a region, because it's flatline and stable and relatively uplifted, that is where our continental divide is, where our watershed is, primarily timber and grazing, and the railroad brought later settlers to this region. Moving south into this region, we are in the Mogollon Mountains and the other surrounding mountains. I'm sure many of you have been to the Mogollons or into the Gila Wilderness, and they look like just regular, pretty rugged mountains, right? But actually, these are something really unique. These are old, eroded calderas, supervolcanoes, like the Valles caldera, except much older and much faulted, folded, and eroded. So that you've got chunks of caldera floor, chunks of ash flow tuff, exactly like the Bandelier, except much older. We're talking 30 to 40 million-year-old volcanoes that have since been uplifted and eroded. Now, these are, there we go. These are, of course, the home of the Mogollon culture and later the Apache, great places to evade the U.S. cavalry. And because it's old volcanism and then uplifted, volcanoes have a lot of heat. They mobilize minerals. And so you get economically valuable mineral deposits. And especially if it's uplifted where you can get at it, it becomes a mining region. So think of Silver City and big copper mines, gold, silver, lead, fluorite, smithsonite. They're all mined in this region. Okay, farther south, the Basin Range, that part that looks like little worms. These are actually parallel mountain ridges and valleys. And they're parallel mountain ridges because when this section of the crust was formed, we were being affected by a change in the plate boundary in California, believe it or not. And as that plate boundary motion changed, it actually pulled apart some of the western North American continent and formed these parallel mountains and valleys. So it's all different types and ages of rock here, and primarily grasslands in the valleys, grazing, ranches, an easy route to the west for early Wells Fargo, Pony Express, Railroad. And this is the area of the proposed Mimbres Peaks Monument. We're going to skip across now the center part and come over here to the southeastern Great Plains. In New Mexico, these are called the Llano Estacado, staked plains. And it's pretty featureless, isn't it, if you've gone to Clovis or Portales. But it's a really interesting section of the crust because beneath the surface sediment, which geologists call by the highly technical term of dirt. So underneath that, we have flat-lying, very old marine sediments laid down by an ocean that covered New Mexico 500 million years ago, 400 million years ago. This is the so-called, and all the way then subsequently until 250 million years ago, when we had a real incursion of the ocean with limestone, marine shale, and this stuff is perfect for forming, guess what? Oil. Yep, this is the period called the Permian period, and you might be familiar with the term because it's also used for the Permian Basin, which is underneath both West Texas and New Mexico in this region. So here we have grasslands and ranches initially, the home of the very early Clovis culture, but we also have the vast economic resources of the Permian Basin oil, and the limestone still is it's also perfect for one other thing, and that's it's easily eroded by water. So this is a region where we have caverns, caves, and sinkholes. Okay, let's move farther north here in the Great Plains. And in New Mexico, these are called the high plains. It's a similar situation here. It's flat-lying sedimentary rocks, but these sedimentary rocks are younger. They're from the age of dinosaurs. They're the same types of rocks that we see in the Colorado Plateau. So it's a little bit more colorful, a little bit more features. They're not the type of rocks that are good for necessarily much in the way of economic resources, but this has been the home of the Folsom culture and later Kiowa and Comanche. It's grasslands, it's ranching territory. There was an attempt, of course, in the early 1900s to turn it into farmland, and it became a major center for the Dust Bowl. Santa Fe Trail found its way through here. Nice, easy, flat paths. But on top of these weird sediments, there's something a little bit unusual, and that's a volcanic field, a young volcanic field. You're probably familiar with Capulin volcano. That's one of just many that form the Raton Clayton volcanic field, which is a pretty young volcanic field. And amazingly, if you start in the middle of the Atlantic and move west across the North American continent, this is the first young volcanism you get to, is here in northeastern New Mexico. Okay, now we're going to tackle the center part. First, central north here. This is the true Rocky Mountains. A lot of people refer to some of the mountains in New Mexico as part of the Rockies, but the true Rocky Mountains only extend south to Santa Fe. These are the southern Rockies. They formed a long time ago, 65 million years ago, at the end of the age of dinosaurs, by collision and compression of the North American continent. They're very old rocks, old faulting, and old mountains, and subsequently changed by glaciers. You can see the remnants of a glacial lake here. This is one of the first places that Anglos, the folks from eastern U.S., came to New Mexico from the north through Colorado, the so-called mountain men for fur trading and trading with Native Americans. It's our source of primary water from snowmelt. And because it's mountains that have been uplifted, also a source of minerals and mining traditionally. So in between legs or arms of the Rockies as they enter New Mexico is something very different. And that is the Rio Grande Rift. So how many of you have heard of the Rio Grande Rift? Oh, beautiful. When I first started giving these talks, very few people had ever heard of it. But the rift is just the most defining feature of New Mexico landscape, New Mexico geology. And here it is. So here's that digital elevation model again. Here's the state of New Mexico. And the rift begins in southern Colorado, San Luis Valley, goes right down the middle of New Mexico and kind of dissipates into the Basin Range in Mexico. It's an area in the Earth's crust where the crust is actually thinning and pulling apart. Now, it's important to note that this is not a plate boundary. You might have heard of the concept of the crust divided into plates that are all jostling and moving apart and together. This is not an area between two plates. We're in the middle of a plate. We're in the middle of a continent. And yet, the crust of the Earth is actually thinning and pulling apart. This is a young, active feature. It only started about 20 million years ago. I know that sounds old, but it's really young geologically. And it's still forming, it's still opening. And it defines much of the landscape of central New Mexico. Now, it's a really unusual situation. We live in a very unusual place in the middle of a rift because there are only 5 young continental active rifts on Earth. We're one of them. I bet you can name one of the others. Where else have you heard of a great rift valley? Yeah, East Africa. Well, here is the Rio Grande Rift and the East African Rift to scale. Basically the same geological animal. Similar level of activity, similar age. The other 3 rifts are the Rhine Valley in Germany, Lake Baikal in Siberia, and a rift that's under the ice in Antarctica. And that's it. So it's a very unusual situation and a very amazing place to live. Now, most of the time when we geologists talk about the rift, we show pictures like this with these nice straight lines defining the rift. But that's not really the way it is. If you roll out pizza dough or pie crust and roll it out and then you want to stretch it a little bit, it starts tearing, and it doesn't break in two straight lines, does it? It sort of opens up as a series of ovals. And that's exactly the way the crust of the Earth works. So here's the real situation. The rift actually is a series of oval basins, and each basin is sort of dropping down and filling with stuff. Either it's material that's coming off of the highlands surrounding it, or other things that will fill it. And these turn out to be perfect places for all kinds of things. It's way better to build a town or a city on flat, level ground, right? So take a look. This is where most of our biggest major cities are in basins of the rift. This is where there's enough dirt and soil to do agriculture. This is where the Puebloans settled after leaving the ancestral Puebloan great houses, where the Spanish colonists originally settled. And this is a perfect place for trails and routes, including, of course, El Camino Real. There's one other thing it's perfect for, too, and that's the river. Most places, the river cuts its own channel over time. But the Rio Grande has been able to take the easy way. We have a through-going, almost interconnected series of low spots, right? So it's a perfect place for a river to come down. So if you take a look at a satellite image of central and northern New Mexico, here's Taos, Santa Fe, Albuquerque, you can see the river just finding its way down the lowest basins that are interconnected there between mountains, between ridges, between the margins of the basins. The Rio Grande actually started as an integrated river about 3 to 4 million years ago. And it just, remember, the rift started 20 million, so yeah, no problem. It just took one look and headed down the lowest path from its origin as rainfall, snowmelt, and water in the San Juan Mountains. Now, in some places, it got stuck, and it had to carve its way through an area. One of those is White Rock Canyon, just up the road. Another is the Rio Grande Gorge. A lot of people think the Rio Grande Gorge is the rift, but it's not. The rift is that whole Taos Valley there, and the river has just carved down through it to get through that section. In some areas where the river has widened and it has a floodplain, it has produced an outer valley that it has eroded. But that's pretty recent, only about 100,000 years ago in the Albuquerque area. And even more recently, the inner channel, the current channel of the river and the Bosque, only 10,000 years old, blink of an eye in geologic time. And of course, the Rio Grande has captured all the other rivers and streams that it could, even ones that used to go east-west. And they are all now tributaries of the river. But if not for the rift, New Mexico would not have a through-going, life-giving river. So, what happens at these basins? I mean, you're down-dropping a chunk of crust, right? So, first, it's surrounded by a series of faults along which different sections of the crust are moving. And you and I drive up or down one of these packets of faults in between two basins of the rift whenever we go to Albuquerque or Santa Fe. La Bajada, that's why it's there. This is the marginal fault between two basins of the rift. The other thing that's going on around the margins of the basins is that just the way these faults move geologically, it's just the way they work. One side kind of drops down, the other sides kind of lift up a little bit. And this becomes what we call our rift marginal mountains. Now, taking another look at the rift, there are some mountains that are volcanic, like Bahamas and Mount Taylor, but from Albuquerque south, just about every mountain range is long, linear north-south. And if you listen to the TV meteorologists, they will frequently talk about the central mountain chain, right? What they're talking about are these rift marginal mountains. They're not part of the Rockies. They're not old. They're young, and they're there because of the rift. They formed as the rift formed. So a good example is the Sandia Mountains in Albuquerque. If you drive from Santa Fe to Albuquerque, you see them, and they look kind of weird. They look like they're steep on one side and not on the other. That's because they are. They are a stack of rocks, basically, that have been lifted up and tilted back as the rift formed. Similar thing has happened south of Albuquerque, all along the rift, with the Fra Cristobal Mountains, the San Andres, the Oscura, and the Sacramento. If you really look at their shapes, they are uplifted, tilted back mountain ranges, only there because of the rift. Relatively young features, 10 million, 5 million years or so. What about the Sangre de Cristos, though? They look a little different, don't they? Well, actually, the Sangre de Cristos are part of that southern Rocky Mountain belt. They're part of the true Rockies. They're old mountains formed by compression, not by uplift. 65 million years ago, old rocks. But as the rift formed, they also lifted up a little bit because of the movement of the rift. So they're actually dual mountains. They're both Rocky Mountains and rift marginal mountains that have been sort of reactivated by the formation of the rift. So that's what's going on with these basins. What's going on inside the basins? They fill with something. The river brings a lot of sediment down. It spent most of its life filling in the basins of the rift rather than carving it. And it still brings a lot of dirt and debris down. That's why it's mostly brown. Also, you've got material coming off of the highlands that are filling the rift basins as they form. And in the Santa Fe region, this has resulted in the really beautiful Santa Fe Badlands near the opera. And in fact, in all of the state of New Mexico, whenever people talk about rift fill, they call it the Santa Fe Formation. That's the official name of this unit. But it's not just sediment that fills the rift. There's something else too. As the basins of the rift thin, the mantle of the earth actually gets closer. It bulges up, and it gets closer to the surface. And with it closer to the surface, and of course, these basins have a lot of faults associated with them in the geological sense, not in the other sense. You get a perfect situation for volcanoes. And in fact, New Mexico can be called the volcano state. We have as many as 1,000, 1,000, if not more, individual volcanoes. Some of them are depicted here by yellow dots. We have old volcanism. We talked about that for the Mogollon Daddle area, and that's shown in orange. But we have a lot of young volcanism, younger than 4 million years, and sometimes as young as 4,000 years. Now, a lot of this, much of it, is associated with the rift. Those red patches that are oriented this way. We have a second patch of young volcanism that is oriented this way. Some people have called this the Jemez lineament because it goes through the Jemez, but it actually marks a very old suture zone, fault zone in the crust of the earth. So it has been active at the same time as the rift volcanism has been active, and makes New Mexico an extremely volcanic state. In fact, we have every type of volcano defined by volcanologists, and there are 9 or 10 different types depending on the definition. We have an example somewhere in New Mexico, and they come in all shapes, all sizes, and all ages, from 40 million years to 4,000. In fact, you could call New Mexico an outdoor volcano museum. Unfortunately, working at the Natural History Museum, I can't collect the things I study. But outside, you can actually go from volcano to volcano and, in a sense, collect them. My colleague, fellow volcanologist and husband, has an interesting theory about these young volcanic volcanoes, young dynamic volcanism in Mexico. He has postulated that that feeling of dynamic volcanism actually affects the creativity in New Mexico. And if you look, the cities that are considered centers of art in New Mexico are all adjacent to volcanic fields. So there may be something in it. So in New Mexico, we have a plethora of volcanoes. They start with very old, iconic features like shiprock, and wind up with two of the longest young volcanic lava flows in the continent, in North America. Valley of Fires goes also about 5,000 years old. El Malpais near Grants, about 4,000 years old. Pretty amazing. And that 4,000-year date, that means the folks, the ancestors of Acoma and other pueblos were here and witnessing that. New Mexico even has a supervolcano, just like Yellowstone, okay? It's a little bit older, not too much older, and it's actually a better geological example. It is right next to Santa Fe, and in fact, if you look at the satellite image, you can see that it looks pretty darn close to Santa Fe. This is the caldera, and this is the eruptive material that was erupted from the last eruption. Now, supervolcanoes aren't just, a big volcano and the top blows off. There's something different. They're usually long-lived group of volcanoes. The magma chambers coalesce, and you have one amazing convective eruption as the magma chamber empties and basically leaves a big hole in the ground. And that's what the Jemez Mountains and their Valles Caldera are. So here's the caldera here. It is humongous. It's 12 miles, 20 kilometers in diameter. And a lot of people drive up San Diego Canyon and stop here, look at the overlook, and they say, wow, look at the size of that caldera. Well, they're looking at this part. Okay? They're looking at Valle Grande, not the whole caldera. This is a humongous volcano, and it last erupted about 1.25 million years ago. Yellowstone last erupted about 600,000. But some of these volcanic domes within the caldera are as young as 40,000 years. So it is considered still active. There is a magma chamber beneath the ground near Redondo Peak. And of course, when it erupted, it sent out pyroclastic flows. Some people think this is sandstone in San Diego Canyon. It's not. It's ash flow tuff. It was a rolling hot gas cloud of debris that was so hot that when it slowed down, it welded into solid rock, hundreds of feet thick. So when you look at the profile of the Jemez Mountains, this is a view from Museum Hill. What you're actually seeing is the caldera. The caldera extends from about here over to here. So it is a big feature. But Santa Fe has a volcanic field that's even closer. And I bet you probably haven't heard too much about it. This feature right here, right outside Santa Fe, at its doorstep, is not part of the Jemez volcanic field, even though it looks it. This is a separate volcanic field. It's the second largest volcanic field within the rift, and I call it Santa Fe's volcanic field. Okay, this is it right here. See the difference in the topography. Now, geologists have called this the Cerros del Rio volcanic field, but you might know it better by another name that's become very prominent, and that's the Caja del Rio. It's part of the Caja del Rio grant, La Majada grant, managed by the Santa Fe National Forest. It extends all the way from White Rock Canyon to Tortilla Peak to to I-25. And it is an amazing volcanic field. Evidence of ancestral Puebloan. Here's a petroglyph here. Lots of potsherds, walls built, beautiful open space, just 10 minutes away from Santa Fe. Just go past the animal shelter and the Laboratory of Archaeology, and you're there. And a population of wild horses live out there. Now, I'm enthusiastic about this area because I'm the one who was privileged to map it when I was a graduate student back in the 70s, and I've continued to work on it since then over the years. When I was mapping, I camped out in the field, and these cowboys had been hired by the Forest Service to cull some of the wild horse herd because there were too many for the pasture. The cool thing was they gentled them then and used them as their own riding mounts and on their ranch rather than selling them. So it was a fun experience for me to interact with them and find out what was going on. The field itself is a gem. It's about 40 individual volcanoes, all basalt, about 2.6 million years old. It predates the Valles Caldera eruption, and therefore, when you look at White Rock Canyon, you are looking at layers, lava flows, and in some cases, cinder cones of this volcanic field deep in the depths of White Rock. There are volcanic necks and cinder cones, remnants down at the river if you climb all the way down to the base of White Rock Canyon. And for those of you who have done rafting through the canyon, you might have seen what looked like sediments, lowered dirt in various areas. Those aren't sediments, those are volcanic ash. Because what happens when an eruption comes up through water is you get a steam blast eruption called a Mare crater. And White Rock Canyon is just full of remnants of these Mare craters. Now, I have to show you one cool thing. When I was mapping, I discovered this, and it had been unknown before. This is an aerial photograph. You can see this kind of weird circular feature right on the edge of White Rock Canyon. Here's the power line road here. This is one of those steam blast volcanoes called a Mare, M-A-A-R, from the German word for lake, because all the mares in Germany are filled with water, so they're lakes. Okay. I named this Montoso Mare. It's a unique example, and volcanologists who specialized in Mars came from all over to look at this with me, because you can start at the top and walk all the way down to the base, where you'll find columnar basalt. Really amazing feature. And the reason I'm going on about this is because I'm very worried about the proposed bridge power lines to Los Alamos, and would hate to see this feature covered or destroyed, because it truly is unique, just like so many other features in New Mexico. Okay, phew. That was a long time and a lot of information. And so finally, the summary. So we all live in one of the great rift valleys on Earth, and it's a perfect place for agriculture, settlement, trade. We have rocks in New Mexico from 2 billion years old to 4,000. We have a major river and river system that I call the gift of the rift, because if not for the rift, it wouldn't be here. We have old Rocky Mountains, but we have young rift marginal mountains. We have lots of volcanoes, both old and young, and volcanoes provide us with fertile soil and mineral deposits and maybe creativity. And we're surrounded by classic Southwestern scenery. So that's my story. I think we have a few minutes for questions before we adjourn and talk more outside. So who has a question? Yes?
I think it'd be worth mentioning that very near Santa Fe is the Jungle Canyon, which is a remnant of the Mara volcano that you're talking about.
Yes, exactly. Good, exactly. Sorry, he said I think it would be worth mentioning Diablo Canyon. Now, there have been a lot of names over the years for that region. Near the Buckman Road, near the old bridge across White Rock. That area, it's been called Ceja, it's been called Buckman, it's been called Diablo Canyon. It's also part of this volcanic field that I was discussing, and the remnants of lava flows of volcanic center and Mar volcanoes. Another question. Yes. There are 2 of you right behind each other. So let me do the back one first. Yes. Yes.
Ortiz and Cerritos.
I was going to put that in, but I thought, oh gosh, that's too much. The Ortiz and Cerritos are sort of similar to the lagoons and shiprock. They're the remnants of very old volcanoes. And remember what I said about old volcanoes mobilizing hot water and minerals. That's why those 2 areas are so rich in minerals. The first gold rush west of the Mississippi in the U.S. occurred in the Ortiz Mountains in 1820, and folks still mine gold there. In the Cerritos, turquoise, one of the probably oldest mining districts in North America. The Native Americans have mined turquoise there for 1,000 years. Still turquoise and other copper mineral deposits. So you have a good eye. That's what those are, and that's why they look a little different too. And in front of you, actually, there was a question. Yes.
I've taken
taken a tour of Poye Cliffs a couple of times, and with all due respect to our Santa Clara guides who have said they're up top, flew up and landed was Black Mesa. So
Yeah.
I'm curious about that. How does that seem?
Not exactly. It, in a sense, I mean, the land basically totally became ash and therefore went up into the air and settled back down. But in general, the Poye Cliffs are part of that pyroclastic flow material, the ash flow tuff, that sort of boiled out from the caldera and formed these long linear fingers away from the Valles caldera. Darker areas are lava flows that are remnant lava flows from earlier in the Jaynes mountain volcanic history that are left behind capping mesas. So it all came from the caldera, but not in one lump. Yeah. Yes.
If the Jaynes caldera had not collapsed, what possible elevation would it have been?
Okay. If the Jaynes caldera, the Valles caldera of the Jaynes, did not collapse, what elevation would it be? Probably, actually, not much higher than the rest of the plateau. We're not talking about a Mount St. Helens type volcano that's very steep, or a Crater Lake situation where the top blows off and you've still got a big volcano there. The Jaynes probably started out as a whole bunch of smaller volcanoes, and each one with a magma chamber. The magma chamber is actually coalesced into one big magma chamber. That erupted, and basically, instead of the top of a volcano blowing off, you had a big hole in the ground formed. So it's a different sort of eruption than we used to. Humans have never seen, or at least recorded, one of these supervolcano eruptions. The most recent was 79,000 years ago, and human ancestors were around, but not doing much writing down and recording of stuff. But interestingly enough, that is also a time when there was a narrowing of the human genetic pool. And so it is believed that these massive eruptions put enough material up into the air and cause enough disruption that they can affect at least local, if not regional, populations. If you built a box around Santa Fe and it went all the way up to the top of the Sangres, the floor of the box might be covered by the eruption material from Mount St. Helens. The whole box would be filled by the eruption material from the Valles caldera. So we're talking about a lot of material. Yes?
What is the geological process that created the Glorieta Mesa, and what is the age of the cap rock?
Glorieta Mesa, the cap rock is Permian age, so it's older than the dinosaurs. It's not that marine sediment that I was talking about, though, that you get in southern New Mexico. It's actually beach sand. It's a nice sandstone formed in a beach environment. And during the Permian period, only southern New Mexico was covered by ocean. Central northern New Mexico were land. And so Glorieta Mesa, the Glorieta sandstone, think of it basically as the beach along the ocean. Now, subsequently, it's been slightly uplifted by its association with both the Rockies and the Rift, and eroded. And that erosion has formed the mesa that we see today. Interesting in New Mexico, our iconic landform is probably the mesa. And the way mesas form is you have a layer of rock that's more durable, harder on the top, that protects layers underneath. So in New Mexico, this is frequently a lava flow. But in this case, it's this nice, beautiful beach sand, hard sandstone that's protecting it. Oops, I seem to have messed up here. Here we go. I think we're running out of time for questions, so that's all we can do here. But certainly, if you have questions, grab me outside. But also, Daniel has my email. I'm happy to answer any questions you might have. We went through a lot here tonight, so a lot of information.